All right, so when we look at this problem here, what we want to do is we want to rewrite both sides of the equation using an exponent with the same base. So can we express 9 in terms of a base 3? Yeah, it becomes 3 squared to the x squared is equal to 3 to the 3x plus 2. Now when you apply the power to a power rule, you just multiply, so we get 3 to the 2x squared. And once we do that, it's a matter of equating the powers. We know that 2x squared has to be equivalent to 3x plus 2, and we can set these equal to each other and solve. So here, if we, since we have multiple terms, it's a quadratic equation with multiple terms with variables, so we move everything to one side. So we'll subtract a 3x and subtract a 2. And now we just either factor by rewriting the middle term or by factoring, reverse foiling. Since our first and last, they're both prime numbers, I'm going to go ahead and reverse foil here. We get an overall product, or the overall sum of our outer and inner products is going to be a negative 3. Since our signs are opposite, I'm going to put the negative opposite, the 2x. And then we just need to test a 1 and a 2, or a 2 and a 1. Well, if this was a 2, we would have been able to factor it out. So we know that this has to be a 1. Therefore, this is a 2. Let's test it. Negative 4x plus 1x does give us negative 3x. So we have two possible solutions here. X is negative 1/2, and x is 2. Now, if we plug those in and check to make sure that these work, I'm going to plug it into this form right here compared to this form. Okay, plug in a 2, we get 2 squared is 4 times 2 is 8, so we have 3 to the 8th. Is that equivalent to 3 to the 3? 3 times 2, which is 6, plus 2, which is 8. Yeah, so this one checks. Do the same thing with the negative 1/2. So here, negative 1/2 squared is 1/4 times 2 is 1/2. And we compare that to here when we take our negative 1/2 times 3 is negative 3/2 plus 2 is a positive 1/2. So you see those are equivalent. So both of these numbers work for that problem.